more optimization. Second part. Let's do some cones, huh? Skip past it. There was our steps to solve. All right. We're gonna loosely follow that. Hey, there's the farmer. And we're back on down to, oh, here it is, a cone. So let's get after it, huh? So we got a cone, with a slant height of 6 inches. Is to be constructed. What is the largest possible volume of such a cone? So step 1 says draw a picture. Oh, a cone, something like that. All right. Some shitty cone. We give it a little dimension. Woo! We made a cone. Cool. You got a cone. A cone has a slant height of 6 inches. What the hell does that mean? What's the slant height? Look at the picture. What the hell do you think it is? I think you just, even if you never heard the term before, you're like, oh, this must be 6 inches. This must be 6 inches. Cool. Step 1, we drew a picture. Maybe we'll have to refer back to that in a second, but it's all good. Now, what is the, so we want to get to step 2, right? And step 2, that's all about we want to get an equation for whatever it is we're trying to maximize. What are we trying to maximize here? We're trying to get an equation to maximize, the largest possible volume of the cone, so the volume. And then we're going to need a constraint as well. Constraint, so I'm going to C-O-N-S-T. So we're going to need 2 things here. So let's find the equation. So if we're trying to find what is the largest possible volume of such a cone, so it's in the question. It's right here. The equation is simply just in the question. It's going to ask you, what is the largest possible volume of a cone? We want the largest, so we're maximizing. You know the volume of a cone? Now you do. The volume is equal to 1/3 pi r squared h. Make that a little bit bigger. So there it is. We got the volume is equal to 1/3 pi r squared h. Cool. Now we need a constraint. And what the constraint typically is the way we're going to want to look at it is we're going to want to try and find some sort of relation between h and r. Some sort of relation between h and r. Well, we could just use the idea of similar triangles. When you see a cone, think a triangle. Doesn't it kind of look like a triangle? So here we go. We're going to drop something down. We're going to drop what's called the perpendicular. Let's take it down. Boom. Right to the center of this cone. And let's call that the height. Right? We know there's some sort of height. And now there's also, let's draw this in, so we have our radius as well. And here's our radius. So there's the radius and the height. We got it. Now if we could find some sort of relation between the two that we could plug on into there, I think we could have something. So what do you think? Does this help at all? We're making a right triangle symbol right there, the h squared plus r squared equals 6 squared. So our constraint is, once again, look at this. H squared plus r squared equals 6 squared. It's a right freaking triangle. Lovely. Lovely. It's gonna be good. So here we have it. We're gonna say you thought we were gonna do some crazy stuff. I thought so too. I was losing my mind. Oh, moving back to the problem. So h squared plus r squared is equal to 6 squared. We have an equation. We have a constraint. That's good. Now step 3 tells us we want to just plug that shit in. We want to plug it in terms of one or the other. So we can either solve for h or we can solve for r, or really, you know what's hanging out right here? I know it's kind of hard to read in the way I wrote it. Is this r squared and this r squared. I don't want to solve for h and then go plug it in and have to like do some squaring and shit. You already got r squared. Why don't we just solve for r squared and plug that in, huh? I think that's going to be a little bit simpler for solving this. Oops. All right. So let's go do our third step. Our third step is telling us we want to take this h squared and r squared. R squared is equal to 36 minus h squared. All I did was take that 6 squared is 36 and I subtracted the h squared over. Cool. Now we want to take this and plug this into our equation right up here. This equation, let me just change the color on this sucker so we can see it when we plug it in. So we say the volume is equal to 1/3 pi times, and then instead of writing r squared, I'm going to make a little parenthesis, times h, right? So I wrote everything but r squared because r squared is going to go right in to here. There we have it. It's 36 minus h squared. Now let's start putting everything together in a little bit more of a cleaned up way, and we can say that our volume is equal to 1/3, or how will we write this? Just pi over 3. Maybe bring this in and make it a little bit more palatable, a little easier, because we're not going to want to be doing any product rules, right? Just want to bring that thing in. We're going to say that that's going to be 36h minus, 36h. Let's just rewrite that, huh? 36h minus h cubed. We got our formula. Let's go. Step 4, take a derivative, set that bad boy equal to 0, and solve. Let's go. Let's jump over to the side. I think we have enough of the information. We can go now. So let's take it. So let's go to step 4. We're going to take that derivative. So dv dt from down below. Well, I think this constant's just going to go along for the ride. Let's go. And now we're going to take a derivative on 36h, and that's going to be what? 36. Now let's take a derivative on negative h cubed. That's going to be what? Negative 3h squared. Let's go. And now we're setting this thing equal to what here? We're taking this set. We're just going to set this shit equal to 0. That's right. So look at that pi over 3. That absolutely means nothing to our problem because we're about to divide that sucker out. So now we have that 0 is equal to 36 minus 3h squared. Let's just run through this freaking algebra real quick. You know what I mean? Doing a little something like this. Hit it, and we're going to find out that we have the square root of 12 is equal to h. Typically, we want to reduce this down, right? You're thinking you're super cool right now, huh? 2 root 3. 2 root 3, you got that? I saw that shit too. But for this problem, I don't think we're going to need to really reduce it down. Remember, we're trying to get the answer. But if you saw that, good. I'm just talking smack. So what's the question? We got the height. All right, either one of these, whatever you want. So we got the height. And what's the question? So what is the largest possible volume? Oh, so we just need the volume. So in order to get the volume, we're also going to need, oh, we don't need to do any of that. We can just plug it right back into our formula, can't we? Don't we have a formula for it right here? I thought we had a formula for it. That's all in terms of h. Why don't we just plug it in right into there and see what we get out of it? So we're jumping step 6. Do you think that's a minimum? Do you honestly think that's a minimum? No, of course not. Let me show you. I'm going to give you the slant height of 6. Or the radius is 0. Or how about this, a slant height of 6? Where the height is 0. Those might be the minimums, but what do I know? Not much. Okay, so step 6, we're jumping to that one because I'm feeling pretty confident about it. We want to answer the question. So the volume is equal to, and then from down there we're saying pi over 3 times 36 times our h. And our h was, what did we find? To be root 12. Root 12 minus, and then we're going to cube all that stuff up. That root 12. Root 12, huh? Cubed. Cool. Now what's our solution? Let's go. Let's find it. So we're going to be able to use calculators. And that's cool if you want to write down your answer at the end, but I want to see some freaking exact answers. This is what I call an exact answer, buddy. So this is 36 root 12 minus 12 root 12. So I'm pretty sure if you have 36 root 12s and you subtract 12 of those root 12s, you're going to have 24 of those root 12s. All right, now if you want to be badass, oh, actually, hold up just a second. Hold up a second. The 3 and the 24, that's going to become an 8, right? Is that what we're going to get? So we're going to get some shit like a 8 pi root 12, but we can take that root 12 down and we can break that. Isn't root 12 equal to 2 root 3? Yeah, it is. So what are we going to get? 16 root 3 times pi. Now that's cool. We wrote down a number. I'm super stoked on that. That's nice, but we better put some freaking units in there. So what are we trying to find? This is the volume, and we were talking about inches. So what are we going to say is our answer? We're going to say this is 16 times root 3 pi. And if we're talking volume, this thing has got to be in cubic inches. Now, if you want to punch this thing into a calculator and find out that you get 16 times, I never even do because I'm a math person. I don't really give a shit what the answer is. It could be 3 trillion. I'm like, cool story. It's a number. Cool, but this is actually going to be, that's a highlighter. That's not a pen. That is 87.06 approximately. You know what I mean? Approximately cubic inches, and that would be the maximum volume that we could get such that it would have a slant height of 6 inches. So there it is, and I will see you back in the next one for another fun-filled problem.